Good morning, grade 11. Today we will talk about how we can test the presence of aqueous different cations. Okay? We know that the salt consists of two parts, cations, and anions, where the cations represent the metal ion or the metal positive ion or the positive atomic group, that carry positive charge, and the anion represent the non-metal ion that has a negative charge or a negative atomic group. Today we will talk about how we can test the presence of different aqueous cations. In qualitative analysis for cations, two key observations must be recorded. Number one, or the first observation, the color of precipitate that form it. And number two, the solubility of precipitate in excess of reagent, and the color of the resulting solution after solubility, By using these two observations, we can deduce the identity of the cations, We use aqueous sodium hydroxide and aqueous ammonium hydroxide, Both of them are the reagent, or ammonia solution to test the different cations. Step number one, dissolve the salt in distilled water to remove the impurities. Step 2, add a few drops of aqueous sodium hydroxide. Step 3, observe the color of precipitate. Let's start with the first cation, copper cation. Look at the table, copper cation. By adding a few drops of sodium hydroxide, copper cation gave light blue precipitate. And by adding excess of aqueous sodium hydroxide, blue precipitate insoluble. And in case of ammonium hydroxide or ammonia solution, the copper cation produce also light blue precipitate that soluble in the excess of ammonium hydroxide or ammonia solution, giving dark blue solution. After copper, we have calcium cation, calcium cation and aluminium cation, and zinc, because all of them produce the same precipitate, the same color of precipitate. Look at the calcium. Calcium cation, by adding few drops of sodium hydroxide, white precipitate produced that insoluble in the excess. By adding excess or more aqueous sodium hydroxide, the white precipitate insoluble, But by using ammonium hydroxide or ammonia solution with the calcium cation, no precipitate formed or very slightly white precipitate. Look at to the aluminium. Aluminium, by adding a few drops of aqueous sodium hydroxide, white precipitate, But by adding excess of aqueous sodium hydroxide, the white precipitate soluble, forming a colorless solution, And in case of ammonium hydroxide or ammonia solution, white precipitate formed that insoluble in excess. So, to differentiate between calcium cation and aluminium cation, because both of them produce white precipitate, we added more aqueous sodium hydroxide. In case of calcium, nothing happened, the precipitate can't dissolve, But in case of aluminium, white precipitate disappear and become colorless. The third one, zinc. Zinc, by adding a few drops of aqueous sodium hydroxide, white precipitate will be formed. That's soluble in the excess, forming colorless solution as aluminium, But in case of ammonium hydroxide, by adding ammonium hydroxide with the zinc, white precipitate formed, soluble in excess, forming colorless solution, We have two types of iron, iron 2 and iron 3. Iron 2 known as ferrous iron 3 known as ferric. Okay, ferrous iron, by adding sodium hydroxide, it will produce the green precipitate that is insoluble in excess. And by adding ammonium hydroxide or ammonia solution, ferrous iron produce green precipitate that is insoluble in excess. But in case of ferric iron, okay, what happened? Sodium hydroxide with the ferric iron produce red-brown precipitate that is insoluble in excess. And in case of ammonium hydroxide or ammonia solution, ferric produce red-brown precipitate that is insoluble in excess. Okay. The last cation, chromium cation. Okay. Chromium cation gave green precipitate with the sodium hydroxide, but it differs from ferrous cation. In case of chromium, by adding excess of aqueous sodium hydroxide, it can soluble in the excess. Okay. And by adding ammonium hydroxide or ammonia solution to the chromium cation, green precipitate will produce that is soluble in excess. Okay. The last test, flame test for metal ions. Okay. In this lesson, we describe how to use flame tests to identify different metal ions. Okay. Describe flame imaging spectroscopy if we have a non-salt in lab. Okay. Procedure. First step, we dip a glass rod or platinum wire in water, then in solid salt. Okay. Then introduce it to the Bunsen burner. Second step. Okay. And the color of the flame can be used to identify the metal ion. Okay. Look at the table. Lithium metal ion produce red flame. Okay. While sodium metal ion produce yellow flame, potassium metal ion produce lilac flame, while copper metal ion produce blue-green flame. Okay. So the application. Let's answer and solve this question. Number 1. Ion gave red-brown precipitate with the sodium hydroxide solution. Number 1, we choose C, ferric ion. Okay, the answer will be C. Number 2, ion gave light blue precipitate with the sodium hydroxide solution. 2A, copper ion. Ion gave green with the sodium hydroxide solution insoluble in excess. Number 3, ferrous. So the answer will be 3B. Number 4, ion gave green precipitate with the sodium hydroxide solution in excess and soluble in excess. Number 4, the answer will be D, 4D. Number 5, ion gave white precipitate with the sodium hydroxide solution soluble in excess forming colorless solution. Number 5, aluminium, 5B. Number 6, ion gave white precipitate with the sodium hydroxide solution soluble in excess forming colorless solution. Number 6, zinc, so 6B. Number 7, ion gave white precipitate with the sodium hydroxide solution insoluble in excess. Number 7, calcium, 7D. 7D. Number 8, ion gave yellow color in Bunsen burner. Number B, sodium, 8B. Number 9, ion gives red color in Bunsen burner, 9A. The answer will be lithium. Okay. Number 10, ion gives a blue-green color in Bunsen burner, D, 10D. 11, ion gives lilac color in Bunsen burner, C, 11C, potassium. Number 12, okay, ion gave gray-green precipitate with ammonia solution insoluble in excess. gray, green, chromium. 12D. Number 13, iron gave light blue precipitate with ammonia solution soluble in excess forming a dark blue solution. A, 13A, copper. Okay. Number 12, the last one, iron gave white precipitate with ammonia solution soluble in excess giving colorless solution. The answer will be D. 12D, zinc. Okay. Thank you, Red 11, for your good listening, and goodbye.